welcome everyone. Today, our main topic is focus on performance feature in SQL Server 2022, and we will have Deepthi as our speaker. She's an MVP. She's a blogger. She's a data community builder, and she's one of my first speakers. Right, and every year we have Deepthi. It's always a pleasure an honor to have Deepthi share her experience with our community. As you can see on the call, you see two of us, but the thing is, we also have another one that is, for some reason, I'm not sure why this is not able to click. So the session will be recorded. It's being recorded, and I highly suggest you, if you do not want to be part of the recording version, to do the needful. Um, Feel free to share this community with your peer, your friend, with your coworker, or on your social media platform. So we are three. You have me. I am Jean Joseph and work for Microsoft as a technical trainer. And you have Hunen, which is the primary person that maintaining the data community since last year. And since Hunen took over, things get even better and better. Thank you so much, Hunen. Would you like to say something, Hunen?
No,
Perfect.
we are good to continue.
Yes, and also we have Kevin. In case if you want to speak, I highly suggest you to reach out to Hunen. We have call for speaker for cloud data driven and also for feature data driven. And then, this is a community events. Therefore, we have members join us all over the place. Make sure you interact and engage with us, but keep in mind that do it with respect, okay? And if you wanna keep in touch with our community, we have a couple event. We have Sikobit, which I highly suggest you to register. I'm pretty sure Deepthi is one of the speakers. Who doesn't like to learn from other experts? I don't think. We all love, I do think we all love to learn from others. So I highly suggest you to register for Sikobit. And there's a tons of free events, which is specifically on the weekend, like SQL Saturday, Data Saturday. Feel free to go to this website, sqlsaturday.com and datasaturday.com, as you can see here. And then, for example, save. I'm not sure why this is showing. Give me a second. And for example, reg register for, and what else? We have a Microsoft meetup group that I highly suggest you to join this community on Meetup. And Microsoft Learn is one of my first way to go to keep myself updated. If you want to keep it part of your favorite as well, feel free to do that. So I already spoke me about Sikobit. I'm not sure, Wonen, if you want to say something about this. This is a discount. Wonen have more information about that. Would you like to say something?
No, it's there is not a lot to add. We just got for our community code. So if anyone want to join the meeting, this event, so he can get 5% off from the ticket. But we need to remove it soon because the event is almost here.
Exactly. Perfect. So with that, Deepthi, it's a pleasure to have you. Feel free to share your screen, introduce yourself, and start with your presentation.
Thank you. Let me share my screen.
I
Okay.
highly recommend to share your camera as well in a virtual meeting.
Sorry, can you repeat that again?
I said that I highly recommend to share your camera as well. In a virtual meeting, there is no interaction, so the camera
Yeah.
it's the only way to make it more interact with the speaker. If you have
Right.
the camera ready, so I
I
recommend to share it.
I understand, but I'm really not feeling well. I'm really sick right now, without cough and stuff going on. So I might cough in between the session. So I might blow people's ears because I can't suddenly put mute
That's
and then
okay.
cough. So I hope you understand, and I appreciate your support. I can't come to the camera, not for this today evening. I have one more session. I can't go to camera as well because I'm not doing well. So I hope everybody understands that. Um, so yeah, hello everyone. Thank you so much for taking your time for attending this session today. And I would like to first of all thank you organizers, Jean, Joseph, and Ronan, for giving me this great opportunity to present here again. I spoke past in the past events. I'm glad to be here. So today I would like to talk about the performance features we have in SQL Server 2022. Um, A little bit about me. I'm a data platform MVP and I'm a database administrator, having about like 8 years of experience as a DBA. And I did my master's in computer technology at Eastern Illinois University here in United States. And I do a lot of community work along with the speaking and blogging. I also do organizing. I'm a co-organizer for a couple of user groups that you see there on the screen, and also I do volunteer for women in technology as well, and I do mentor women as well in their IT fields, and I encourage them to speak as well. And apart from my work and then my community work, I love plants, arts, and crafts. And if you have any questions regarding the session, or like if you wanted to grab more knowledge or the extension of this session, please contact me on my Twitter or on LinkedIn. I'm very active on LinkedIn and Twitter. And there I posted my blog as well, dbnuggets.com. I usually blog about SQL Server and Azure. So if you would like to look into, please visit my website. So as an agenda, we are as a part of like SQL Server advanced features in SQL Server 2022. We are going to talk about the query store hints, parameter sensitive plan optimization, memory grant feedback, DOP feedback. These are all the SQL Server 2022 IQP features. And when we see these features, right, the last three from the bottom of the list requires query store to be enabled on the database. By default on SQL Server 2022, query store is already enabled by default. So the only feature that we have to remember, like that doesn't require the query store, is the parameter sensitive plan optimization. So this session will give you an overview of like what all features we have and how do they work. So before talking about the query store hints, if you are not familiar with the how with the feature, right, query store, and how it actually works behind the scenes, the next slide will show like what happens, like how exactly the query store works. So let's say any query running on the SQL Server, the first thing that happens is when a query executes, the first thing that happens is to check whether it is running for the first time or whether it has actually run several times. But if it is running for the first time, right, then it have to go ahead and build the compilation and optimization, and it have to create the execution plan. But if it is not running for the first time, then there might be a plan in the cache already, right? So if there is like there are several reasons why the plans can be flushed out of the cache, like when you restart the SQL Server, or like when you do recompiling, or like when there is a memory pressure, the plans will be evicted out of the cache. So in those scenarios, there can be the plan that not be available on the cache. So in that case, it will go ahead and build a new plan again through compilation and optimization phase. But if there is already a plan, then it will go ahead and use that existing plan. But before moving forward, it will go ahead and check for the recompilation. Like let's say one of the advantages of enabling the query store is you can force a plan so that the next time the execution happens, it will go ahead and use that force plan. But during this phase of like checking for the recompilation, it will go ahead and check whether that plan that is actually taken from the cache or whether the newly built plan is actually similar to the force plan. Like if you are running a query which you already forced a plan, then it will always go ahead and check whether in any scenario, whether it recreates the plan or if it takes the plan from the cache, it will always check whether it is actually similar to the forced plan. But sometimes, like I said, there can be an update to the indexes. You might have added new columns to the indexes, um, and that index is being used in the force plan. You made a modification to that index, right? So in that scenario, sometimes there can be a failure, and it will go ahead and say like, hey, I do not find an exact plan. So in that case, it will build a new plan. And if it is not similar to the force plan, then it will go ahead and apply that force plan. But if the plan is same exact copy of the force plan, then it will go ahead and move ahead with the execution. But before going into the execution phase, the query text and the query plan of that query that you are running will be saved inside the memory, which is known as a plan store. Like when you enable the query store on a database, there are a couple of stores that will get enabled, like the plan store and runtime start store. So, so before moving to the execution phase, the query text and the query plan will be saved inside the plan cache. This process will happen asynchronously, and then the query goes to the execution phase. So when query goes to the execution phase, it first executes and then collect the runtime stat store, because to collect this information, the query have to execute. So it will store these information in the runtime stat store. Again, this is all in the memory. These stores will be enabled once the query store is enabled on the database. And this process happens asynchronously as well. And once the like there are certain intervals that you enable. Once you enable the query store, you also um, you add the settings to it, right? So there is something known as interval, flush out interval. For every 15 minutes by default, all the information that is gathered in the memory, this query text, query plan, and runtime stats will be eventually flushed to the disk. So where does this information get stored on the database? It stores exactly on the database where you enable the query store, and it always save that information in the primary data file of the database. So you cannot change that location, right? It always saved there. And so by default, every 15 minutes, the information will be flushed. But sometimes when there is a memory pressure, when there is too many queries running on the server, then this process can be kicked in even before that 15 minutes interval. So that's how the query store actually works. But then there is like plan cache that is already there when compared with the query store. Like we already have a plan cache where all the cache information, like the cache, the plans will be stored, right? But what is it different from the query store? So with the plan cache, you know that like for every SQL Server restart, all the plans will be evicted out of the cache. But with the query store, all of the data is retained in this information is retained on disk, because eventually it will be flushed out on disk. And the only way that it will be cleared out by setting up the cleanup policy once you enable the query store. So the cleanup policy is for every 30 days in by default. So it will always delete the old unused data every 30 days. And with the plan cache, you can only store the latest plans. But with the query store, it will store the all the information, right? The plans and the um, execution information like CPU, memory, everything will be stored over time. And whenever there is a memory pressure, like I said, all the all the plans will be evicted. But with the flush out intervals, that's when the information from the memory will be flushed out to the disk onto the query store. And with the plan cache, it is very difficult to know why the plan has changed. If at all it changed, it is difficult to track. But with the query store, it gets easy to troubleshoot and to look into the history of the information, um, as not only the plan, but the plan text and everything will be stored, including the execution stats information. It gets easier to solve the problem. So what are the advancements of Query Store in SQL Server 2022? In 2022, SQL Server 2022, Query Store is enabled by default. Like if you are creating any new database on SQL Server 2022, then the Query Store will be automatically enabled. But if you are migrating from the older versions of SQL Server to the newer versions, then you need to, that setting won't be changed. You need to manually enable Query Store. And on SQL Server 2022, there is a threshold limit that they have set for the internal memory limit has been set for the ad hoc workloads. So whenever the memory limit reaches, the internal memory limit reaches for the ad hoc workloads, the query store will automatically go to the read-only mode until the memory, until it releases a certain amount of memory so that it can re-enable again to the read-write mode. And we have query store hints in SQL Server 2022, where you, like, if you have any parameter sensitive problem, you just like the query hints that you use, you can also use the query hints by using the query store functionality, by using a store procedure designed for the query store for this purpose. I will show you that in the demo. So before moving to intelligent query performance, like, let's go ahead and see um, the demo of the query store hints. I hope you are able to see my screen.
Yes,
Can you
we can see
confirm?
it.
Thank you. So, so usually, if you do not have a query store, whenever you want to, like, this is regarding the query store hints, right? So basically, like, if you are having any parameter sensitive problem, or uh, especially with the parameter values, like you have that one or two parameters that will generate like millions of records, and rest of the parameters give like only a couple of thousands of records, there is a skew in your data, right? But if you want to solve that problem, generally we use a recompile for the store procedures, or like any other hints, not only the recompile, but here in my scenario, I'm using the query optimizer compatibility mode. I would like to put it in a 110 mode. So I need to literally change the code of the query, what I'm executing, to use this particular hint. I have to change, I have to use the option and recompile and use any hints within the query. But we do, like, not every time you have the ability to change the code. Your vendor might not be happy about it, or like you need to go through set of like permissions from the higher management to change the code, or your application is suddenly not performing well and you do not have that much of time to work on the code itself. But by using the query store hints, you can actually use the store procedure designed for the query store hints to immediately solve the problem, this sort of a problem, without even touching the code, underneath code. So let's go ahead and see an example how we can do that. So right now I'm using Azure SQL database, but this is the same exact process with the SQL Server 2022 as well. So I'm using AdventureWorks database, and then I'm going to create a simple store procedure here. If you see, store procedure name is sales information. All I'm doing is I'm selecting a couple of columns from the table where the product ID is, I'm giving a parameter value, product ID. I'm going to execute that. And then query store is actually enabled by default on SQL Server, on Azure SQL database. So it's already enabled, but I would like to just clear it out for my demo. Um, Clearing query store is like not recommended on your systems, not even in the development, because it will clear out all the collected data. But here in my demo, I want to do it by altering the database name, set query store, clear will clear out your entire query store data. I would like to do it here. And then I would like to alter and then alter the database. I will also like to clear my procedure cache. So we have this, we just created the store procedure. We have these two sensitive parameters. One will give more records. So I would like to execute at this point of time. And then I would like to also enable the actual execution plan and execute it. So currently it's still executing. Okay, so now if you see the number of records at the bottom of the screen, the first execution as gave the output of 360,000 records, but the second one is just about like 385 records. If you see most of my parameters in my tables, they just give like a couple of hundreds and thousands of records, but this is a parameter which is sensitive, which gave me like too many records, right? But if you see the execution, the first execution that I did after creating the store procedure, where it compiled and like stored the plan in the plan cache, that gave like 360,000 records, which thought like which has created and saved this particular plan, which is a clustered index scan. But the second time I executed the same store procedure, which has given me 385 records, also use the same exact plan. Now, this is not optimal, because if you hover your mouse over there, it has read too many records here. Look at the number of like estimated rows, and like it did the entire scan on the clustered index, which is not optimal here. It could just use an index and do a key lookup to just perform this, to just give this output. So I would like to take the advantage of the query store hint to just to recompile this so that it will use according to the parameter. It will run properly and generate the plan based upon that. So for that, we need to know the query text. So there are two steps that we need to perform here. First, we need to identify the query ID of this particular query of the store procedure. So so by using the query text, right? By using the query text and like operator, I would like to grab the query ID of the store procedure, which is query ID 1. It gives the text. So the query ID 1. Now this is the store procedure I'm talking about. If you are using the query store, right, enabled on the database, then you can use SP query store set hints and give the query ID, which is query ID 1, and then what kind of value you want to use, what kind of hint you want to use. Right now, at this point of time, we want to use recompile to regenerate, to create a better plan for the second value. So I would like to go ahead and run this query so that this hint will be applied. The recompile hint will be applied on that particular plan. So on that particular store procedure. So let me execute this. Now, now currently it is actually being enabled. You can find that hints, what kind of hints are enabled by using this query store query hints view. So I would like to execute to see currently the query hint ID is 1 and the query ID is 1. The query hint text is recompile. That is the latest one, right? That is enabled. Now I will go ahead and execute the same exact um, store procedure with the same parameters again to see if that hint will be applied. So it applied, it looks like it applied. The first one is clustered index scan, but the second one right now it recompiled and generated index seek and the key lookup for this plan. But to know if the plan, like if the query hint has actually been used or not within the plan, right? You can check that by clicking on the properties and by saying somewhere here it shows like whether the plan has been used or not. Mm, I'm just checking.
Yeah, it's right there, option recompile.
Oh, where is it?
Yeah, go
Yeah,
down.
option
Yeah, there.
recompiled, right. You can actually use if this hint is actually being used or not by using this text. It will show you clearly. So that's how you will identify whether it is using or not. So let me close this one. So currently we are using the recompile, right? But you can also use the um, multiple hints at the same time. Like for example, um, like recompile, and like if you wanted to limit your max stop usage, you can also set that without removing the recompile. You just have to append it, because if you remove it, it will automatically override the hints in your for your store procedure. So I would like to use the same SP query store set hints, and then use the query ID one, and then I would like to use two of the values, like two of the hints at this time. So let me execute that. Now we have updated it. Now let's see how it will show actually in the query store hints. Like you can grab like what is currently being enabled. Now if you see, the hint has been updated from the query hint ID number 1 to 2, and for the query ID 1, and currently it is using the option recompile as well as the maxtop one. But do you see, like it didn't have the information of the query hint ID number 1. It has just overwrite it, and then it has updated that value, but we do not see any history. That is how it is set by default. So but if you want to see the history of, like, if somebody suddenly update without your knowledge, you would not know. So how do we get that information? We can use the extended events to to see the actual history of the hints that has been applied for your objects. I have written a blog post about it. You can go ahead and see on my query store. Queries. There is a tab in my website, query store. You can find in that one of the blog post is like how to actually capture that information. You can go ahead and see that. Uh, so right now we have actually updated it to both of them, right? Now let's go ahead and um, clear out the cache one more time, and then run these both executions again. So right now, like it uses the recompile, we can clearly see that. But if you go ahead and see, it will use both of them, option recompile as well as maxstop one. So that's how you can actually take the advantage of like query store hints to fix the problem immediately until you actually see the query and work with your developer to fix the actual problem. But you can immediately solve the issue without like breaking anything, or without changing any underneath code. So to see the currently supported query hints, please follow this Microsoft doc below. You can see the list of query hints that are currently supported. Now let me go back to my slides and share my screen again. So right now, let's talk about a little bit of intelligent query processing features. So this is a huge like table flow chart of like what all intelligent query processing features we have in SQL Server. And the color coded, like in SQL Server 2017, we have, like if you see bottom of the screen, the blue color represents SQL Server 2022. These are all the IQP features released in SQL Server 2022. We are focusing on those today. So the first one we wanted to talk about is parameter sensitive plan optimization. Most of the IQP features, which you are seeing in blue, uses the query store. That was one of the reasons why they actually by default enabled it on SQL Server 2022. Except parameter sensitive plan optimization, rest all them uses the query store. So if you forcibly disable the query store, right, that means like you cannot use any of these feedback information that is being collected from the query store as well. So it is recommended to keep that turned on. The highlights before going further is like there are no code changes needed to use any of these IQP features, except like you need to just update the compatibility mode of your database to the SQL Server 2022. And it's not like once you update the compatibility mode, these IQP features can work together. A single query can use multiple IQP features together. And you can see the performance impact, like the performance improvement once you enable it to the latest compatibility mode to 2022, you will see the difference. Query store advancement we have talked about, but I put this slide together because like there are a couple of other advancements as well in query store. In SQL Server 2022, query store can capture the information on the secondary replicas as well. Previously, before 2022, SQL Server 2022, only primary replica on the primary database can capture the information of your queries and save it on the primary database. But by enabling it on the secondary replica, all the data will be captured from the secondary replica and will be sent it over to the primary replica and will be saved on the primary database, all the information. And it's enabled by default, and query store hints, we talked about it, and rest all of them are the IQP features that we are going to discuss. So let's talk about the parameter sensitive plan optimization. It is also known as PSP optimization. So this is the only features that doesn't require the query store to be enabled. So it doesn't use the query store information, right? So it has something built-in technology on SQL Server 2022, which is known as a dispatcher and the variant plans. Let's talk about what are those, right? So let's say you have a parameterized query, and the parameter is query sensitive parameters you have, and you want multiple plans, right? You can't just keep on using the recompile. And based upon this PSP optimization, basically what it means is like if you have a parameterized query, the SQL engine, it will go ahead and save up to 3 different plans in your plan cache. So the internal technology is like known as like dispatcher plan, which is basically the logic which will hold the logic, just like the way the index tree looks like, right? On the top level, once it hits, it will know where it have to move and grab the data. Just like the index tree, we have this something known as like the dispatcher plan, where it have all the logic, like which plan I have to use, what type of indexes do I have to use, and where I have to grab that information, like based upon like how many rows of output I get, which plan do I use. So up till maximum, it can use 3 plans. So let's say we are running a query, right, which have an agent with uh, with with so many listings, and this dispatcher plan will have a logic, right? If the agents have like less than 10,000 of listings, go ahead and use the plan. Like seek and lookup is enough, and use this plan that I have saved in the cache. But if it has 10,000 to 1 million listings, then just go ahead and use the scan and grant medium memory grant, which have a different plan. And then the same way, we have a third plan. If it is more than 1 million listings, go ahead and do a entire clustered index scan and then use the large memory grant. And all of this logic and the plan information where it have to go will be saved inside the dispatcher plan. So the plan itself is known as a variant. The name is different, but it means the variant means a plan. Now let's go ahead and see.
Definitely.
Yeah.
Before you continue, we have a great question from Saraf. His question is, where is the query store information saved, where it is stored, when we are using, for example, DB, which is in read-only mode.
So if you are placing the database in the read-only mode, um,
I was talking about the replicas. So secondary replica,
oh yeah,
you mentioned earlier.
I think I
Secondary
have
replica is read-only
I
mode.
mentioned. Yeah, I mean, I should have a slide about it, but I missed
Is it
having a slide
is it
about it.
saved like in the
So
temporary database?
no. So if you are having the always on availability group and like primary and the secondary, right? If you enable it on secondary because it is a read-only database on secondary, you will actually use the primary database to actually enable it on the secondary. Because it is a read-only, you can't execute any um, even to enable the query store on secondary, you have to do that on the primary database, and all the information that will be captured will be using the same pathway, like how the data will be transferred from primary to secondary. It will use the same pathway to send the data back from the secondary to the primary, and the data is always stored on the primary um, primary replica only.
So when I'm running a query on secondary replica, which is completely different, I don't run any query on primary. If I'm
Mhm,
running a bad query, good query on a secondary replica, all the
mhm,
query plan, the stats,
mhm.
and everything on the secondary replica, how does that get transferred and saved in the query store on the primary?
Right, I told you, right, it uses the same exact topology, like it will use the same exact pathway, like how it sends the data from primary to secondary, it uses the same from the back in a back way, like from secondary to primary, it will send back the data to the primary. I don't know the exact internal because I read in the documentation if I could find how exactly they do that, but they only mentioned like it uses the same pathway to send the data back to the primary.
Okay, I'll look at it. Thank you.
Saraf, in general, the information is stored in system tables. Those
Generally,
system
it is always
tables,
stored in the primary, it's always stored on the database where we enable the query store, and it always stored on the primary data file. We can't even change that.
yep, okay,
It is part
that's
of
your
it.
answer.
It is part of the database, not the system database.
No, it is a
Yes,
part of the database. It will be
but
saved
it's in the
inside the
system.
primary data file.
Yes, it's the
System
system.
table.
Yes, in the
And
database.
I won't
And
take too
then you
much
can
time.
view it through
I don't.
views.
I won't take too much time, but I will just want to mention this that we have a server with 800 database, and we enable query store on all of them. And the server, after a month or so, with as the activities continue to increase, the server basically crashed because the amount of data was being inserted, cleaned up, and all that stuff. So you have to be very careful with the query store. It is a very good idea. It works well, but it should be used in a very controlled fashion, being that it is enabled by default on SQL 2022. We start with disabling all of it and enable as needed. Just a suggestion.
Yeah,
So from
and
my
also the
perspective,
configuration too. How the interval flush intervals and what is the
Correct.
cleanup and how much space you are actually allocating and what sort of a queries you are doing. Because you have the ability to actually give the threshold of CPU and how many times the query have to run to even be captured inside the query store. You can actually set those, and you need to be very careful while doing those. And you can play on the lower environments to figure that threshold out, but if you can set that properly, then you will be only capturing the information you need, because by default it will also capture the ad hoc queries, and if you have too many ad hoc queries, you need to make sure you run the SQL agent job, and you have a query on the SQL docs where you can eventually clean up all the ad hocs as you go, and you can schedule that as a SQL agent job and schedule that on on a regular basis.
Yes, thank you.
So let me go ahead and share my screen again. Okay, so we are going to see right now how the PSP optimization is used. I'm using SQL Server 2022 and Stack Overflow database. So it's already enabled the queries, but because I migrated, let's see, Stack Overflow database is old one, right? So I need to enable the query store on this particular database. So let me go ahead and enable. What is this error? No, I did not connect to um, SQL Server. I connected to Azure SQL database. So let me connect to, all right, now let me enable and right, the configuration details that I was talking about. These are the configuration, how you actually set up the query store is really important. Again, with the ad hoc, I really suggest everybody to go ahead and use the custom policy of, so custom policy meaning like you will be choosing how much threshold of CPU it have to hit and how many times the query have to run. So those sort of things. But here in my demo, I'm just executing a sample. And So once you enable the SQL Server 2022, your parameter sensitive plan optimization will also be turned on. But I'm just showing a T-SQL of how you can alter, right? Alter database scope configuration, set parameter sensitive plan optimization, turn on. I didn't do that in database, right? I didn't do that in database. Let me do that. Database. Okay. Now I put the database in the compatibility mode, latest compatibility mode, SQL Server 2022. Now, this is a very simple store procedure that I would like to execute. All it is doing is select star from users with where reputation ID ordered by display name. So I executed that. So we are using where reputation, right? In the where clause, we are using reputation. So let's go ahead and see how the statistics of that reputation columns look like and what is how the data looks like. So this is actually what we are watching here is a statistic on that particular reputation column. And if you see the equal number of rows for the values, right, for the range high key value, if you see, so it says like with the value of reputation ID 1, we have these many equal number of rows. So these are just the value of the reputations with rows. So I have just grabbed the range ID 1 and I took couple of parameters here because if you see for this value, we just have how many rows, equal number of rows, 1. So that's how like it will show like if you see the distribution of data, if you see the equal number of rows for different um, reputation values, it differs, right? There is a lot of skew in this table, in this column, sorry, with the reputation value. So I am taking couple of values of reputation from that statistics, and then I'm running each one 3 times with each one, and then enable the actual execution plan on and see the execution. So the first three, it uses index seek and key lookup, still running, right? Um, so, so the first one used that, and the second one is using clustered index scan, still executing based upon the values it decided. So we are seeing this database is in SQL Server 2022. Now, because it executed index seek and key lookup, it didn't use the same execution plan. If you see, it is using different plans. So the last two executions used clustered index scan, but the first execution used index seek and key lookup. So um, now if you see like this is a plan cache. Now I wanted to see how many plans are saved inside the plan cache right now. Usually it will save just one, but here with this particular PSP optimization, you see the number of times of executions for each of those parameter values, and it generated two plans, right? This is one plan, and the last two executions used one plan. So two plans are saved inside the plan cache by using PSP. Now, if I scroll down, I can see different like all the information like dispatch. I'm scrolling down because like the upper queries will give the exact output of this bottom query. So here, if you see, like if I execute this particular, we can see the dispatcher and the variant plans by using this particular query. Now, if I execute that, now you remember like the variant plans are nothing but the store procedures, the same exact store procedure that the dispatcher plan, the logic have all the logic will be saved inside the dispatcher plan. But these variant plans are the exact plans that got generated. So if you see the dispatcher plan, I think I can open up the dispatcher plan here. Dispatcher plan doesn't give anything. It doesn't give any exact uh, like the execution plan kind of thing, but it shows like the multiple plan. So this is a dispatcher plan which have all the logic. We can't see it here, but it have the logic that will um, show the like a tree of information, like where it have to go for what sort of a plan depending upon the parameter value. So you can find that information as well. So I thought of showing something else here. Uh, so if you see like I thought of showing something here, but I think on this.
Should the query ID be same?
Yes, the query ID will be same, but the plan ID will be different. That
But
is
if
what
you
like
look
I'm
on, but if you look in the output, the query ID is different.
because we executed different queries as well, right? Um, the plan ID differs, but the query ID should be the same. Um, Variant query ID. I think that information will be shown properly on this query, I believe. I put many queries together to show, like let's execute this and see. So dispatcher plan is just one dispatcher plan ID and parent query ID and then variant query ID. If you see, the variant query ID is the plan ID. Query ID also shows different here. Why does, because we executed the other queries as well, but let's see the queries here. Or maybe I skipped something here, maybe. I'm sure the demo didn't break. I'm just trying to figure out what I skipped here because I skipped a couple of queries, right? So uh, I'm just thinking it should show like if you see the results, it shows like the query text is actually the same. Um, the query hash, the query hash is the same, but the plan ID differs. If you see the variant query ID is a plan ID differs, but what you are saying is like, why do the query ID differs?
I guess because of the parameter.
No, it should not happen, right? Because the same store procedure. I didn't realize this until now. Until now, I didn't realize this. So let's see this. Uh, let me execute this. Yeah, so query hash is the same, but the plan hash should be different. But I never focused on the query because the query text is the same with different parameter values, of course. Um,
But this is 2022, right? So
yes,
2022
this
will
is
have a parameter-based plan. So you will have a different plan for different parameter.
yes. So this is a plan hash. So they differ, right? Plan hash is different. So the plans are different. That means the query ID should be the query hash is the same. If you see,
Mm-hmm.
when the query hash is the same, it should have the same query ID. Did it show the query ID here? I'm just trying to, um, because the query text, I think I have to look a little bit more in it. Yeah, the like, so if you see the queries, right? The what is this query text? It has a different query text. Because the variant it is saving the variant IDs as well, different variant IDs. Maybe that is the reason.
Correct.
If you see,
Because of the
yeah,
parameters.
yeah, because of the
Mm.
Parameters.
plan, that plan information is saved there. Yeah, that is the reason, right? Oh, but I have to dig a little bit more into it. Good to point out. Thank you for pointing this out. Because it saves the variant ID, maybe that is the reason why the query text is different. Right. So let me go back to my slides. Yeah. So before, like, we completed that demo, and now we wanted to talk about the memory grant feedback, persistence, and percentile. So, like, let's talk a little bit about like how the memory grants will be allocated to a query. This is just an overview of how the like how the memory grants are allocated. So whenever a query executes on the SQL Server, right, it goes internally, it goes through some transformation phases, and it will generate certain couple of plans. And on each of the plans, the cardinality estimates are gathered, meaning like the statistics information. Cardinality estimates are the statistics information on the columns um, used in your table, used in your query. So when you run a query, it sees all the columns that you are using, goes and check the statistics to decide like how many rows it can pull and how much of like memory grant it have to allocate. Everything is like depending upon the estimates, the cardinality estimates. So it will check the cardinality estimates on all of those um, plans that got generated, but based upon the low cost, what plan will be the low cost value that will be chosen, and it will be saved inside the plan cache. Then the plan cache, when it goes to the execution phase, before going into the execution phase, based upon those statistics value, the memory grant will be allocated even before the execution of the query, and then the query gets executed. Now, what if this particular cardinality estimates are like your statistics are stale, basically? And SQL engine will go ahead and check those statistics to decide how much memory grant it have to allocate. So if the statistics are stale, it will definitely uh, allocate wrong amount of memory grant. Like if the statistic shows like this particular query just produce like 10 records, but in fact the actual execution will produce like some millions of records, then there is a lot of difference, right? The estimate is will tell SQL Server to just grant the memory only for the 10 rows. But as it goes to the execution, it produce 1 million, which SQL Server don't know how to execute it. So it will use different ways to to execute that query. For example, it will spill to disk, and those sort of things get affected based upon this cardinality estimate. So if the estimates are wrong, then it will affect the way it choose the proper plan. And I'm so sorry. So the wrong plan will be saved, and wrong memory will be granted, and everything gets affected, right? So that's how much important the memory grants are as well as the estimates are. So here with the SQL Server 2022 memory grant feedback, it will actually go ahead and use the cardinality estimate um, to make sure allocates the proper amount of memory. But if those statistics are stale, then it have to spill to the disk. In SQL Server 2022, um, it will avoid, like the process will avoid to remove the spills. Like the main goal is to remove any spills and to increase the concurrency workloads that are running at the same time. And memory grant feedback in SQL Server 2022, um, they have these advancements of like checking up the feedback, taking the history of the information from the query store, and then applying the feedback based upon the history of the executions. In SQL Server 2017, we have this feedback on the batch mode, and on SQL Server 2019, we have it on the row mode. And memory grant feedback on these two versions are not persisted upon the SQL Server restart, but with the SQL Server 2022, even like it will persist upon the restart, as well as if you have to fail over, right? Even then, the data will be persisted. It is not lost. And um, and one of the main reasons of why it gets persisted is that it uses the query store information um, to save these feedback, to grab the information and to allocate the feedback. So before SQL Server 2022, the memory grant feedback is only checking the last execution, not the history of the executions, but the last execution. If you see the picture over here, if, for example, the first execution requires 800 MB of memory, right? Um, but then the last execution used only 5 MB. It will allocate only the 5 MB because it is solely depending upon the last execution. Because of that, it can fluctuate very quickly because it is only allocated on last execution, and we do not know what kind of parameter comes next in the execution. And we cannot rely on this particular process because there is a lot of fluctuation, and eventually the memory grant feedback will be turned off if it sees more fluctuations. But in SQL Server 2022, because it uses the query store data, collects the information over time, it checks the feedback. First of all, it will check if the query will actually be eligible to check for the feedback, and then it will wait for number of executions to grab that feedback, and eventually it will make sure like it will even out that feedback, like how much amount of memory actually needed for that execution. I need to cough again. I'm so sorry, I'm like coughing terribly. So the main goal is to actually avoid spilling to disk, right? A little bit about the cardinality estimates. We have discussed in the previous slide about the cardinality estimates. So these estimates uses like column level statistics, right? To get these estimates, how many number of rows uh, do we have to expect as an output? And it always depends upon the data distribution and how many times, like whether you are updating your statistics properly or not, and how like updating statistics have the percentage values, like how you have to update those statistics as well. So depending upon the statistics, like we discussed, the memory, CPU, the kind of joins that we have to use inside the plan will be depending upon those cardinality estimates. So based upon, like we have like three different cardinality estimate techniques that will be used. So something known as predicate independence versus correlation. So SQL Server will always use the predicate values that you have in your queries. Like for example, you are searching on two different columns, let's say in the where clause, where city is Frankfurt and pin code value is this. So those two columns are actually related, right? The state as well as the zip code. If that is the scenario, then the SQL engine will go to the default value, which is a predicate independence. It will check like those two columns doesn't have the relation between both two columns, right? Doesn't relate. And I'm not going in depth into these techniques, but this is just an overview. Predicate independence is like it will see those two column values where you are searching on as an um, independent predicates, and based upon that it will check the feedback. There is one more thing as containment. Containment is all about the joins, how many joins you have in the query, and what are those join values. Like containment is related to the joins, and row goal is again like how many rows it might get as an estimate. So these are the three techniques that it will use. Again, I'm not going in detail, but it will always check on the, like it will always make sure if the query actually is eligible to do that cardinality estimates. If the estimates are like different, like 10x different or 100x different, if they are like if they are showing too much of different, then it will make sure like it will verify, and then it will keep on like checking on the feedback and make sure one of the plan will be persisted upon the validation. One plan will be validated, and if it decide to put that plan, then it will make sure it will use the query hint to make sure that plan which is persisted, like that plan to be used for the next execution through, again by using the history of information as a query store, and also by automatically enabling the query hint to use that persisted plan. Again, to use this feedback, you need to make sure like database is in SQL Server 2022 mode, and it is only like, again, the query plan will be persisted and used by using the query hint only for the repeated queries. The queries have to run um, multiple times with the with a certain, like it have to use the persisted plans through the feedback. It will make sure it will force that particular plan to be used. And the DOP feedback, I will go a little bit on this one. Degree of parallelism, like if your queries doesn't have to use the parallelism to run your queries, then this particular feedback will make sure it checks the history of the, again it will check the history of the executions from the query store information, and it will always make sure it will decrease the CPU limit up to 2. It cannot go below CPU2, or it will never increase, that value. Again, um, it will always use the validate method, and then it will have to use the number of times the query have to run validation, and then it will validate to certain amount of time through the number of executions, and then it will stabilize the DOP value. So I have covered the overview of what kind of IQP features we have, and we have gone through a couple of um, demos as well. So if you there is a lot more to this particular topic. It's a very vast topic. If you want to know more about this topic and like see plenty of demos on this one, I would like really refer you to this particular video as well as other resources here. And I would like to thank you. I think I have gone over one hour, but thank you for taking your time for attending this session.
Outstanding. That was a very good presentation. As always, thank you so much, Deepthi. If you do have any questions, feel free to post that. Otherwise, I will stop the recording and say thanks to all of you and thanks to the presenter, which is
So
Deepthi.
if anybody wants to have the slides and the demo stuff, I will share it in here on Teams. Let me share it on my Teams.
Chris, I see that your hand is up. Do you want to speak? It was a mistake.
Sounds like no. I think we all set one more time. Thank you. I'm gonna stop the recording. Thanks, Deepthi, and thanks to all of you. Don't forget to reserve your spot for our upcoming webinar. Yeah, enjoy the rest of your day. Thank you. Bye bye.